Welcome to this channel. In this particular tutorial, we will be simulating the biasing the current mirror circuit using the Ltspice tool. For more such videos, I request you to like, share and subscribe to my channel below. Now open a new schematic and select the PMOS transistor and place another PMOS transistor on the schematic. In order to rotate and mirror, use Ctrl plus R and Ctrl plus E. Now select the voltage source for this particular tutorial and right click on this and define the voltage source as VDD. Now extend the wire across the VDD and click on ground and place the ground on the negative terminal of the voltage supply. Define the value as 1 volt. Now extend the wire across the PMOS terminal and PMOS terminal across the both transistors of PMOS. Now, in a normal given circuit, a resistor is used to set the bias current that would result to a dependent on the power supply value and the temperature. The reference current are linearly dependent on VDD. The output current is dependent on both the reference current and VDS of transistor M2. So generally we want reference current that isn't dependent on the power supply or ground variation. So the resistor is replaced with the ideal 10 microampere current source. So you will see the 10 microampere current source which is placed in this particular tutorial. So place the current source and define the value of current source as 10 microampere and define it as I reference as shown in this particular circuit simulation. Now once all the connections are done, we have to define the models for our PMOS. Now we must include the PSIM4 model for the simulation of this particular circuit, and we have to appropriately define the length and width of the transistor M1 and M2, which is shown in this particular circuit design. So include the PSIM4 model text and place it on the schematic. Now click on the spice analysis and we will do the DC sweep. The name of first source to sweep will be VDD and type of sweep will be linear. The start value will be 900 millivolt and stop value will be 1.1 volt. Now when we do the simulation, what happens is that we can see the output current variation with VDD is much better than the reference current. So the reference current through M1 is constant. It is desirable to have a bias current that does not vary with changes in VDD or ground. So this particular simulation showcases that. Thank you for watching this tutorial. I hope this has helped your learning purpose. I request you to like, share and subscribe my channel below.